Hi, this is part 2 of the LuckGrib May 2022 update video series. In the first video, I talked about everything except for the new ability which has been added to the weather routing system, which is for the solver to consider a vessel heaving to as part of its solution. So if you haven't seen the first video yet, you should probably watch that as well as this one. So let's just get started here. So I've set up a scenario where the vessel's in the middle of the Atlantic, heading east, and as it has been traveling, a weather system has come off of the coast, the U.S. coastline, and is now going to overtake it. The comfort settings for this vessel are a bit artificial. They're quite low, and I've done that to make this example better. And towards the end of the video, I'll change the comfort settings and show some more alternatives. So yeah, let's pretend I've just downloaded this weather file and I'm at sea, and I've asked the weather routing system to find me some new paths. So here's what we see for the first example. So starting out from where you are, the system has found a path to the target point, which takes just over 7 days. It travels 1,200 nautical miles, and it's basically sailing downwind, or just around the beam or downwind for about 2.5 days. And by that time, the weather system has moderated to a point where it's able to make a turn and then head back towards the destination. So this path, it's kind of ingenious in that the system was able to find this path through this complicated weather system, which satisfies all of the criteria which have been set. But as a skipper, I would be hesitant to sail an extra, 2.5 days to a turn, and then plus recovering all that distance I've lost to get to a target point. I'd be asking myself, what are the alternatives to this route? If you sail this far out of your way to avoid some conditions, given a weather forecast which is at that point will be 7 days old, there's a decent chance that if you make this decision to head off to this turn point 2.5 days away, that by the time you get there, the weather forecast will have changed again, and your brilliant plan to do this and avoid the worst of the weather conditions may fail, and you'll hit some weather anyway. So I'd be wondering to myself, well, what are my alternatives? An obvious thing to do would be to relax the comfort settings, and I'll get into that approach later on. But I'd also be curious to see what happens if I was to, rather than sailing for the entire journey, if I just hang around where I am now, and what will the weather systems look like in 12 hours time or 24 hours time. So one way to answer those questions will be departure planning. So weather routing is a tool. You don't need to use the settings in the way that they're described. So if you're at sea, you can use the departure planning tool to explore questions about what happens if I slow down by a lot, or how sensitive are these solutions. So let's try that. I'll turn on the departure planning ensemble, and I'll generate 12 hours. So I'll generate 12 solutions, each spaced by 12 hours. Okay, so I have a bunch of alternatives now. So this one, let's have a look at the table here. Starting it on departure time. So the first departure, D1, is the one we just explored. The second departure is interesting in that if I was to hang around the start point for 12 hours, it can generate a path which is over 200 miles shorter, and it's over a day shorter. So even accounting for the 12 hours of hanging around where I am, it'll still get to the destination before the first example. So if I go to the end of this path, I think I'll simplify the display. Go to the end of this second departure. You can see that the first departure is still quite a ways back. It has 23 hours before it would arrive. So that seems like an obvious choice. If I either slow down drastically or find some way of waiting 12 hours or sail slow for this first portion, that may end up being faster than going so far downwind. Going 2.5 days to a turn point, you can instead go for a day and a half to this turn point. So if I was considering sailing this far out of my way to make this turn and come back to the destination, this comparison tells me that rather than sailing at full speed downwind, away from my target, if I go as slowly as I can downwind, then I may have a faster turn. I may end up being a faster journey. So that's interesting. If we go look at more of these, so it looks like the third departure, it wasn't able to find a solution at all. It ended up with all of the solutions hitting the maximum comfort settings and then failing. Same for the fourth departure, the fifth departure, sixth departure, and then the seventh departure. So now we were waiting for 3 days at the start point. And if you do that, if you wait for 3 days, then it finds a solution again. But one thing to note is that in the timeline, part of this update is that the timeline now has a color bar showing you the sailing modes for this solution. So if you notice that if we go back to the first solution, the color bar is all green for the whole duration of the solution. The second departure is offset by 12 hours from the start point, and it's all green. And now going back to the seventh departure, it's offset by 3 days. So its starting point is 3 days after the original start point. And it has a red section. And what's happening here is that the vessel is starting out in conditions which exceed the maximum of the comfort settings. In the past, before this update, if this was the case, the system would just fail. It would come back with a message saying that the initial conditions exceed your comfort, and there's no solution. And it could do that. I mean, that's a valid thing to do because you've set up some maximum comfort settings, and if the vessel's in something which exceeds that, then there's no solution. But that's not very. As part of this update, I've decided that with the ability to heave 2, rather than doing that, I'll instead heave 2. So even though this vessel has not been set to be allowed to heave 2, because the initial conditions exceed your comfort settings, it will heave 2. And the assumption is that, well, if that's where you are, there's no alternative, so I'll try and give you some help rather than not helping at all. So this seventh solution, it shows that if you wait for 3 days at the start point, even though you heave 2, looks like the heave 2 duration is 21 hours. So with this solution, you wait for 3 days, presumably that's all heave 2, and then you wait 21 more hours, and at that point you can start sailing and get to the destination. So if we look at that, this path just above it is the one, the second departure. So I wonder, looks like this departure arrived at the target before the second one. Yeah, it's 4 hours ahead. So these are pretty extreme conditions. So this shows you that if you wait for 3 days at a start point, in the departure ensemble. You wait 3 days and then wait 21 more hours, hove to, and then depart. You're able to beat the vessel, which was the second departure, waiting 12 hours. So clearly there are alternatives. Going back to the first solution, this one, the 7-day route. So this is the one which went for 1,200 nautical miles for just over 7 days. And now we see that there are some alternatives where if you wait around or presumably sail very slowly for a while, there may be some alternatives. So this is showing that you don't need to sail full speed all the time. There's some good alternatives if you slow down. And obviously for sailors, one way of doing that would be to heave to. So vessels typically can't just stop at sea. You could put a sea anchor out, I guess, but it's a bit of a hassle. So that's the process of slowing down like that is heaving to. So with this update, I've added the ability to allow a vessel to heave to. So if I change to this other vessel and open up the settings, there's a new setting in the comfort settings below the maximum wind speed, which is allowed to heave to if the wind speed is less than some threshold. So in this case, I've set it up so that this vessel has all the same settings as the previous one. And the only difference is that this option is turned on where it's allowed to heave to if the winds are less than storm strength. So let's give that a try. And I made the vessel red, so it stands out. So it finds a solution. In this case, it's able to continue sailing from the start point, and it enters a hove to section here. So looking at the timeline, this is the first red group. So it just hove to, and hoves to for a while, and it sails again, and then it heaves to again, and then it continues sailing. And this solution, if I look at this one and compare it to some of the others, here's the first departure is way back here. So this one has 3 days, 6 hours before it arrives. So comparing the solution where it heads off, if it's respecting the comfort settings the whole time, it travels for 7 days and 1,200 nautical miles. Whereas if it leaves at the same time, but it's able to heave to, it's able to make this path where it travels for 3 days, 21 hours, going 500 miles, so less than half of the distance, less than half of the duration, even though it's hove to for just over a day and 8 hours. So even though the previous vessel was using departure planning to generate all of these paths, the system, if it's able to optimize for heaving to, it can do better. The departure ensemble I generated for the first vessel was departing every 12 hours, which is a pretty coarse departure time for studying this kind of this kind of problem. In reality, once you kind of narrow down, maybe you want to choose a second departure as something you want to study more, you could narrow down the departure times to maybe be 3-hour intervals surrounding that departure, or 1-hour intervals surrounding that departure to find out the better one. But rather than doing all that, you can just simply turn on the setting which allows the solver to consider heaving to, and that can find a more optimized path. So I'm hoping that people don't need this, that if with proper planning and a little bit of good luck, you can avoid conditions where you encounter gales at sea or wind strength and wave conditions where you do need to consider heaving to. And I think with proper weather tools that we have now, the weather forecasts have improved dramatically over the last decade. And tools like LuckGrib, for example, allow you access to tools to help you consider and explore options much more easily than in the past. So I'm hoping that even though the product can now support heaving 2, or support your ability to think through that scenario, that you don't actually need this at all, ideally. Not very often, if you need it at all. So normally I wouldn't use departure planning. So the way that this would normally be set up, I think, I'll go back to this vessel. And let's change it. So when you download this update and start using weather routing, by default, the setting for heaving 2 is not turned on. You need to opt into this. And I recommend that everyone just turn that on. And the other alternative with heaving 2 is this new option in the routing ensemble settings area, which is to try with and without heaving 2. So those two settings go really well together. You want to turn both those on. And what happens now, it'll turn off the departure planning. So now it'll create two solutions. It tries to solve first for being allowed to heave 2. So this is the first route it would have solved for. And it did see that it actually did heave 2. It was allowed to heave 2, and it did heave 2. So it made a new solution, which is the second one, where it's not allowed to heave 2. Most of the time you run the solver, hopefully the system won't be running into conditions where it needs to heave 2, in which case it will only make one path. So typically, if you set both those settings on, there'll be no penalty for doing that, because only one path will be generated most of the time. And when it does create 2, then that allows you to study or to recognize then that there is some heaving 2 or some conditions along the path which are more extreme, and you can consider your options, including these 2. So given a choice of these 2, well, I guess typically, so the philosophy of LuckGrib is that it's trying to help you understand the weather conditions. And some people may choose to follow a path that's generated, but I encourage you to use these paths and alternatives as ways to increase your understanding of the weather conditions and make your own decisions about where you want to go. So given these 2, I certainly wouldn't go 7 days out of my way, although I may do that if what was happening was a hurricane. If this was not this artificial comfort settings I have set at the moment, if instead it was hurricane strength winds down here, then yeah, I would certainly travel away from that as fast as I could, waiting for things to improve. In this particular example, that's not the case. So for these conditions, I certainly wouldn't travel 7 days, or travel 2.5 days to a turn point, hoping that the forecasts agree or cooperate the whole way. But I may also not do this path where it does heave 2 directly. There may be some mixtures of these 2 which are worth considering. One point to be aware of is that the system, so looking at the literature of weather routing, I wasn't able to find anything which talked about how to model the performance of a vessel when it's hove to. I think in general, people have spent a lot of time modeling performance of boats when they're underway, because obviously that's what is happening most of the time. But what happens with a vessel when it's hove to will vary greatly depending upon the vessel shape, the hull shape, the vessel style, model, the sail plan, how you actually do heave to, what your strategy is while you're hove to. So I've made a simplifying, so solving the actual movement of a vessel while hove to is, I claim, enormously complicated. And rather than solving that, I've made a simplifying assumption, which is that the vessel remains stationary. And yes, I know that's not what actually happens. The vessel will move somewhere. It may either forage slowly or drift slowly. So if you do use this path, you need to be aware that as the vessel enters the Hove 2 process, it's going to move. So it won't simply restart the path from the same point at the end of this, 12-hour section. So you need to account for that. And obviously, if you're doing this, you'd be downloading weather and solving the routes continually, looking for a good time to get going again. So yeah, hoping you don't need this, but if you do, LuckGrib can now help you think through some of the options you have when you're Hove 2. So I mentioned at the beginning that this example was a bit artificial in that it made the settings, the comfort settings, such that it made a more extreme example. So I'll just fix that. So I've had it avoiding wave heights greater than 4 meters, which, depending upon the winds and the waves and if it's crashing or not, is artificially low. So let's change it back to being able to heave 2, but avoiding wind speeds greater than 30 knots apparent. And if you do that, then it will again create 2 paths. So this Hove 2 path, well, these 2 paths agree for the first, what is this? Travel time here is 14 hours. Looking over here, it's 14 hours travel time to where these 2 paths diverge. And then the path where it heaves 2 simply continues on, and it seems like it heaves 2 for an hour at this point, and then it keeps on going, and it's able to get to the destination. How long is this one? So the path which heaves 2 can get to the target in 2 days, 18 hours. And if you don't heave 2, it takes a bit longer. And it goes 40 more miles. So this path, rather than continuing on to heave 2, it seems like it turns downwind. Yeah, it turns downwind. And then it waits for the conditions to improve, goes to the beam, and then looks like it's slightly upwind. It's reaching now. But at this point, the true wind is 16 knots. The apparent wind is 20. So this is probably more of a typical, what you'll see more typically. Hopefully you're sailing in conditions that aren't extreme. You aren't sailing in hurricane or strong gale conditions. And the differences between these 2 paths just will helpfully give you more options or more ways to think about the conditions and improve your understanding of what's going on. That's the intent anyway. So yeah, this has been about take 47 of this video, trying to make it understandable. I hope it actually succeeded. Hope you can understand some of the capability of the system of this new heaving 2 setting. Let me know in the comments if you want more information or if this is good enough. But yeah, this has been the May 2022 update to LuckGrib. Have a great day. Bye.